Good day everyone. So today for another video we'll be talking about the component method. Now, the component method is a way of adding vectors, but before we proceed, let's review your Cartesian coordinate plane. So in your Cartesian coordinate plane we have this x-axis, which is the horizontal line, and your y-axis, which is the vertical line. So let us say we have coordinate of 2 and 1. So let's say this is, maybe this is 1 and 2 and 1. So if we're going to plot that on the Cartesian plane, then we have this point in the coordinate plane. So the x component is 2 units from the origin, that is 1 and 2, and 1 through the x-axis, and then 1 unit from the origin through the y-axis. So if we're going to connect the point to the origin, then we have this image. So now, the x component is 2 units from the origin. So we can draw this as 1. And then you can draw a line on this to represent your y component. Now your well, let's proceed. As you can see, we have made a right triangle here. So a right triangle. Now, let's go back to your rules in right triangle. Let us call this side as your x. So let us put this side and this on your x-axis, and then this one, let's make this a solid line. Okay, so as you can see, we have here a right triangle. So this one, let us call this side as x, and this one as y. And this side, let's call this as theta. So in equation, we have this, or let us say, this side of the triangle is what we call the hypotenuse. Okay, now remembering your right triangle trigonometry, we have your SOHCAHTOA, or sine is equal to opposite over the hypotenuse, cosine is equal to adjacent over the hypotenuse, and tangent is equal to opposite over adjacent. So let us say we are trying to, and another one, according to the Pythagorean theorem, this side is also equal to, let us call this side as your c. So according to the Pythagorean theorem, c is equal to the square root of x squared plus y squared. And here, theta, how do you find the value of your theta? According to this, we have your value tangent theta is equal to the opposite side over the adjacent side. Now the opposite side of your theta is your y, and the adjacent side is your x. So that is just a review on your Cartesian plane and right triangle trigonometry. Okay, now let us apply the component method in adding vectors. But first, we are going to try it on one vector. Okay, consider our displacement, our vector here. Okay, so this is a displacement. Okay, so 10 centimeters, 35 degrees west of north. If we are going to draw that in our Cartesian plane, it says that it is 35 degrees west of north, and the magnitude is 10 centimeters. So our vector is in this part, and this angle is equal to 35 degrees. The magnitude is 10 centimeters. Okay, let us identify the x and y component of this. So the x component is this one, this side. Now before we proceed, this is 35 degrees, then this is also equal to 55 degrees. 55 degrees plus 35 degrees is equal to 90 degrees. Okay, so why are we going to use this one? We cannot use this 35 degrees since it is from the north. So our angle should always begin on this side, on the x-axis. Okay, so it is equal to 55 degrees. So finding the x component of this, that is from this point to this point, that is the x component. Now you see, this is, if the x component is right in here, then you can say that it is a negative value. Okay, so let's go back again to your rules in right triangle. So this is our angle, that is 55 degrees. So the x component, we are trying to find the x component. This is the hypotenuse of the triangle, and this is your x component, and this is your y component. So let's find your x component. So we have your cosine theta is equal to, according to our rules of right triangle, cosine theta is equal to adjacent over the hypotenuse. So this is our angle. The adjacent side is your x, and your hypotenuse, over your hypotenuse. So this time, let us name your hypotenuse as your d1. So cosine theta is equal to x over d1. Okay. So your d1 is the magnitude of your vector. Okay, so now let us try to find for the value of your x component. So cross multiplication, we have x is equal to di cosine theta. d1 cosine theta. Okay, now x is equal to, the value of your d1 is 10 centimeters cosine theta. Your angle is 55 degrees. Okay, so that is just your one component. Now look at it, we have your x is a negative value, so we shall make our x component should be a negative. So we have your x component that is negative 10 cosine 55 degrees. Okay, next, how about the y component? So the y component now is equal to, since it is a positive y, because it is on the upper side of the y-axis, so we have 10 sine 55 degrees. Okay, you understand that? Okay, now let's proceed to your displacement 2. Displacement 2 is 15 centimeters southeast. So this is your south and this is your east. Now southeast, so it means at the middle of your south, at the middle of, or it is between south and east. So it is between south and east. So it is in the fourth quadrant. So if it is at the middle, then definitely this is 45 degrees. And as you can see, this is 15 centimeters, and as you can see, it is on the fourth quadrant, wherein the value is equal to, the coordinates are equal to a positive x, since this is on the right side of the coordinate, and a negative y, since it is on the lower side of your vertical or your y-axis. Okay, so we know that the x component is positive and the y component is negative. So the x component for this one is equal to 15, since it is a positive x, cosine 45 degrees, and the other one is a negative 15 sine 45 degrees. Okay, let's continue until the x component of the x and y component of your displacement 3. So It is 12 centimeter, the magnitude is 12 centimeter, and then 18 degrees south of west. So south of west, this is your south and this is your west. So it is 18 degrees south of west. So this angle is 18 degrees and this is 12 centimeters. Okay. Now, at this side, on the third quadrant, the values are negative and negative. Okay, the x and y component are negative and negative. Okay, so it means that our x component is a negative. Okay, negative 12 cosine 18 degrees, and the y component is negative 12 sine 18 degrees. Okay. What do we do next? We need to add all those x component, the summation of your x component. So, negative 10 cosine 55 degrees plus 15 cosine 45 degrees minus 12 cosine 18 degrees is equal to negative 6.54. And then your summation of your y component, 10 sine 55 degrees plus negative 15 sine 45 degrees plus negative 12 sine 18 degrees, that is equal to 1.29. Okay, now we need to unify those two. Okay, so that is not yet the resultant vector, but that is just the x and y component of your resultant vector. Now we unify those two using your Pythagorean theorem. So according to the Pythagorean theorem, your resultant displacement is equal to the square root of summation of x squared plus summation of y squared. So d sub r is equal to the square root of your summation of x is negative 6.54 squared, okay, plus 1.29 squared. Okay, the square root of those two, dr, is equal to 6.67 centimeters. So that is now the magnitude of your resultant displacement. Okay, now that we have the magnitude of your vector, that is equal to 6.67 centimeters. Okay, so let us find now the direction of your vector. So using your ratio tangent theta is equal to the summation of y divided by the summation of x. So tangent theta is equal to, your summation y is equal to 1.29 divided by negative 6.54. Now we have your ratio tangent theta is equal to 1.29 divided by negative 6.54. Okay, so to get the value of your theta, then we need to divide both sides, or we have the inverse tangent. So we have theta is equal to 1.29 divided by negative 6.54 inverse tangent, or arctan. So we have your theta. The value of your theta now is equal to negative 11.2 degrees. So that is the value of your theta. Okay, basing from the components of x and component of y, it has a negative and a positive. Negative, positive. So your x and y component, we have negative x component and a positive y component. So at what quadrant can we find those values? So we can find those values on the second quadrant. Okay, so since the x component is a negative and the y component is a positive, and we have your angle 11.2. So our resultant vector is on this part of your Cartesian plane. This is 11.2 degrees and this is 6.67 centimeters. So writing our resultant vector, okay, so let us write our resultant vector here with a direction. Okay, so your resultant vector d sub r is equal to 6.67 centimeters, 11.2 degrees north of west. So it is here, it is 11.2 degrees north of west. Do you understand that? Okay, so let's try another example. Okay, so this time we have our vector in force. So we have our force number 1, that is 18 Newton north, and F2 is 50 Newton 32 degrees west of south, and F3 70 Newton northeast, and your F4 is 18 Newton west. Now we are going to find for your F sub R, or your resultant force. Okay, first let us try to plot them on the Cartesian plane one by one. Okay, so our first vector is 80 Newton north. So it means that our first vector is on the y-axis. It is 80 Newton north. So the magnitude of this is 80 Newton, and it has 0 x component. So writing the x and y component, it has 0 x component, therefore our x component is equal to 0, because that is also equal to cosine 80 cosine 90 degrees, and that is equal to 0. Now here, how about the y-axis? The y-axis is equal to, since that is 80 Newton, so that is 80. Okay, next is your F2, that is 50 Newton 32 degrees west of south. So west of south is on this quadrant, so that is 32 degrees. Now we cannot use this one because we need this angle. Okay? So this angle is equal to how wide is this angle? If this is 32 degrees, then the other angle could be a 58 degrees. Okay, am I right? 58 plus 32, that is equal to 90. Okay, so that is 58 degrees. So we are going to use that angle. So this is your x component. This is your y component. So both are, your x component is a negative, of course, because it is in the third quadrant, and your y component is also a negative. So we can say that the x component of this F2 is 50 or negative 50 cosine, your angle is 58 degrees. And then your y component, that is negative 50 sine 58 degrees. Okay, now we proceed to your third force. Third force is equal to 70 Newton northeast. Means that we are on the first quadrant. That is between north and east, so it means that the angle is equal to 45 degrees. And this is 70 Newton. So the x component here is a positive, since we have a positive x. Then the y component is also a positive. So, writing our x component, we have positive 70 cosine 45 degrees, and we have 70 sine 45 degrees. And then last, we have our last vector, that is 18 Newton west. Okay, so it is in the west, it has no y component. So we can write our y component, that is 0, and your x component, that is equal to what is the magnitude, that is 80 Newton. So it means that the x component of this force is equal to 80. Okay, so now we add our x component. So we have negative 50 cosine 58 degrees plus 70 cosine 45 degrees plus 80, that is equal to negative 65.86 Newton. Okay, now next we add your y component, that is 80 minus 50 sine 58 degrees plus 70 sine 45 degrees. We have your y component, the sum of your y component is equal to 87.1 Newton. Okay, using the Pythagorean theorem, using the Pythagorean theorem now, we are going to find the magnitude of your resultant force. So F sub r is equal to the square root of summation x squared plus summation y squared. So F sub r is equal to your summation x is equal to negative 65.86 squared plus 87.1 squared, and that is equal to F sub r is equal to 109.2 Newton. So that is the magnitude of your vector. Now we proceed into the direction of your vector, that is tangent theta is equal to your summation y divided by summation x. So tangent theta is equal to your summation y is 87.1 Newton divided by negative 65.86 Newton. We have theta is equal to 87.1 divided by negative 65.86 arctan, and that is equal to theta is equal to negative 52.9 degrees. Okay, if we are going to draw that, as you can see, we have a negative x and a positive y. So negative x is in here and then a positive y. So we have your vector, your resultant force is on the second quadrant. Okay, and that is 52.9 degrees. So if we're going to graph that, then your vector should be here. Sorry, it should be here. So the magnitude of this is 190.2 Newton, and the angle that is equal to 52.9 degrees. Okay, let us write your final answer. Your F sub r now is equal to 109.2 Newton, and the angle is 52.9 degrees. The direction is north of west. Okay, so that is our final answer. F sub r is equal to 109.2 Newton, 52.9 degrees north of west. So that is how you solve, that is how you add vectors using your component method. I hope you learned something today, and that's all for this video. Okay. So now, let us talk about how you are going to make your performance task on your vector addition. So, what you're going to do there is a graphical method. It's the graphical method of adding vectors. Okay, so we have your Cartesian plane. Let's say we have your three vectors. We have number one, let's say our F sub 1, or the first one is 13 Newton south. And then F2 was 18 Newton 30 degrees north of east. And then we have our F sub 3 is let's say that is 10 Newton, let us say southwest. Okay, so how are you going to use the graphical method for vectors? Okay, so we have to draw your Cartesian plane using your graphic paper. Okay, use rulers and protractors to measure your angles, and your use ruler to measure your magnitude. Okay. Now, first, we have our first vector that is 30 Newton south. It means that we are going to move 30 Newton, whatever measurement, whatever measuring tool you are going to use, measuring unit. Let's say we are going to have a equivalence. Let's say 10 Newton is equal to 1 centimeter. So in your ruler, you are going to measure a line that is 1 centimeter if the given magnitude is 10 Newton. So in this case, we have 30 Newton. So we are going to measure 30 centimeter that is south. So it's going south, so it is here. Okay, 30 Newton south. So let's say this is 30 Newton. Okay, let's make it longer. Now next, you are going to draw another Cartesian plane. Just make it a dash line. Okay, so you are going to make another Cartesian plane, and then there. Okay, next is 18 Newton, 30 degrees north of east. That is 18 Newton. So we are going to measure 1.8 centimeters. Since our scaling is 10 Newton is 1 centimeter, so we will use 1.8 centimeter. Okay, so from this one, north of east, it is 30 degrees north of east. So it means that we are going to measure an angle here of 30 degrees, and then this should measure 1.8 centimeters. Okay, and then what you're going to do is to draw another Cartesian plane at the tip of your third vector. Okay. Just make sure that this is dashed, because you will connect your final vector to your origin. Okay, next, the last one is 10 Newton southwest. Now our scaling is 10 Newton is 1 centimeter, so this is now equal to 1 centimeter. So we're going to measure 1 centimeter that is going southwest. So if that is southwest, it means that it is between south and the west. So therefore, the angle should be 45 degrees. So we have here our answer. Okay, so this would be it. Okay, let's just imagine that one. But be sure that when doing this, you are using your ruler, and then you are also using your protractor to measure the angle. Okay, so now here, this is your last. This is the last vector. So what you are going to do now, the distance from the origin, this one, the first Cartesian plane which you drew, and the distance between them, the endpoint of your last vector, that is called your resultant vector. So what I'm going to do is to measure this one, measure the magnitude of your resultant vector. Okay, and then you also measure the angle, okay, between your vector and the nearest x-axis. Okay, so you're going to measure this angle, that is your theta, and then the magnitude of this one, that is your f. So that is what you're going to do for your performance task on vector addition. And then later, you will use the analytical method or the component method to calculate or to check whether you've got a near value. Okay, you are going to measure this, and if this is near to the answer which you will obtain on your component method, then you have measured correctly. Okay, if your angle is also the same as the angle which you calculated, then you have a very good measuring skill. So I hope you enjoy doing your activity for vector.